Hello, everyone, and welcome to the webinar Carbon Credits Currency of the Next Decade. My name is Ronald Dadia, Principal Analyst here at Lux Research, and I will be moderating today's session. And presenting today is my colleague Mukunda Kaushik, Senior Analyst here at Lux Research. Now, throughout the webinar, you can type any questions you have in the question box on your screen, and time permitting, we will answer all of your questions. If your question does not get answered, please don't hesitate to email it at questions@luxresearchinc.com, and we will respond. And if at any point you experience technical difficulties, please refresh your browser and check that the internet connection is strong. Now, let's jump into the presentation. Mukunda, over to you.
Thanks, Renil. And thank you, everyone, for joining today. So as you can see from the title of this webinar, we're talking about carbon credits as a currency, right? So why currency? Essentially, a currency is something that can function as a unit of account, right? And has a value attached to it that's quantifiable. And several parties agree on that magnitude, and no one can say that it's less or more than what it actually is. Second, it stores that value over time, right? So you can hold on to it for many years and plan investments around it. And lastly, it can be traded, right? So you can cash in that stored value and get something of equal value in exchange. And carbon credits today are moving in a similar trajectory, right? So it's about the value, the permanence and durability, and what you can get out of it. And that's what we'll explore today. So in today's webinar, we'll start by looking at the current state of the CO2 removal or the CDR market and answer what are emerging CDR technologies that are coming to market. Then we will look at trajectories and shifts, right? So how has the deployment and price of different CDR technologies changed over the last few years? And lastly, end with an outlook and some key takeaways. So starting with the state of CDR today and also why CDR. At the end of 2025, the European Union agreed on its new 2040 climate target, and it set a target for 90% emission reductions by 2040 compared to its 1990 levels, with an interim milestone of about 70% by 2035. And as you can see in this figure, the EU has made progress on its emissions between 1990 and 2025, reducing it by about 37% over the last 25 years. But that level of reduction that's needed from now until 2040 is a lot more steep and will require significant effort. And as a result, the EU is actually increasing the role of CDR in meeting this target. The EU will allow the use of high-quality international carbon credits, right? So the cap of CDR is 5% of the baseline 1990 emissions. And the EU has actually increased this from the earlier proposed 3%. And these credits can be used after 2036, after an initial pilot of 2031 to 2035. Now, 5% may seem small, but 5% of that 1990 baseline translates to roughly 250 megatons of CDR capacity, which is actually quite significant. Moreover, this is a big shift from the EU's earlier stance on not allowing the use of international carbon credits for ETS compliance after 2020. And the shift will come with making sure that there are stronger developments in accounting and standards for carbon credits. So if used properly, carbon credits can actually complement, not replace, domestic decarbonization, helping sectors with hard-to-abate emission sources in particular. And with this policy in place, it's really important for the EU to actually determine which international credits will be allowed and which won't. Because you have a lot of options today in the voluntary carbon markets with varying prices and risks. And that's what you see on this slide here. We won't go through each one today, but we broadly segment them into nature-based or land-based solutions, CCUS solutions, and newly emerging ocean-based solutions. Within land, you have options like forestry, wetlands, and soil carbons, which the EU already doesn't consider. But you also have nature-based solutions that use some level of technology for production or monitoring. So things like biochar made with gasification or pyrolysis, or enhanced rock weathering with basalt, olivine, silicate rocks. Within CCUS, you have direct capture or DAC, bioenergy with CCS, so that's typically biomass combustion, And then you also have sequestration of biogenic CO2, so from biomethane or slurries or bio-oil produced from biomass. So in this case, you generate removal credits because the CO2 from biomass is considered renewable. So by storing it, you go from carbon neutral to carbon negative. And you have CO2 mineralization as well in concrete and aggregates. And lastly, within ocean-based solutions, you have direct ocean capture, which is the extraction of dissolved CO2 from seawater using electrolysis or electrodialysis. You have ocean alkalinity enhancement, which is when you increase the pH of seawater so it can naturally uptake more CO2 from the atmosphere. You have biomass sinking, which is when you grow offshore biomass farms, typically algae or kelp, that uptake CO2 and then gets sunk to the floor. And then very conceptual concepts of artificial upwelling when you add vertical pipes to create an updraft and downdraft of nutrient-rich deep sea waters to stimulate biomass growth on the surface. So I'm sure in the audience today, each of you has strong thoughts on what is considered good CDR, and you've probably dismissed a few of these options simply by the one sentence description that you heard. The EU is doing exactly that, right? And that's how you create compliance markets. So the CRCF, or the Carbon Removals and Carbon Farming Framework, is an EU-wide voluntary framework for essentially certifying removals, which will essentially have an impact on which CDR technologies get adopted and which don't. The European Commission published the CRCF framework in December 2024, and the first certifications will be recognized and issued in 2026, after which these certifications will eventually be moved to a central EU registry. Right? So what the EU is doing now is hosting technical workshops that are essentially deciding whether a specific CDR technology will be adopted or not. Right? And this is really important as voluntary markets move into compliance markets. So you've seen all the options available for CDR, but what are companies on the ground actually buying? Right? So in the last 2 years, companies purchased about 13 megatons of carbon credits from projects that are beyond forestry. And BECS, or bioenergy with CCS, and DAC stand out as the top two in terms of purchase agreements. Right? So despite their high price today, the market is showing that there is growing demand for. And if we look at transactions in the last year, there are three key themes that stand out in terms of what companies are looking for. First is that there is an appetite for engineered CDR and novel CDR pathways, even if these pathways are pretty exploratory. So we see Microsoft buying 6.5 megatons from a smaller BECS company called Atmosclear. And you also see Frontier purchasing credits from Planetary's Ocean Alkalinity Enhancement Project. And in both cases, the quantity is worth noting, right? We're not looking at a few hundred tons or a very small scale project. You're looking at hundreds of kilotons or even megaton scale purchase agreements. The second is a trend in the type of companies that are purchasing credits. Today, Microsoft is still is the biggest customer, and the number of customers tend to be a smaller amount, right? But we see signs of early corporate engagement. So, for example, Boeing recently bought 100 kilotons of credits from Charm Industrial, which does bio-oil storage. The aviation sector has invested in direct air capture before, so they've directly invested in startups because it's an offset tool, but also because it's a source of CO2 feedstock. But now we see the aviation sector engaging more with biogenic CO2 or bio-oil storage startups because that also serves a dual role, right? So offset and then also potential feedstock source for biofuels. The shipping companies are also starting to get involved, right? So they are purchasing credits, as you see here, Mitsui OSK Lines purchasing credits from ocean-based companies like Captura, which is doing direct ocean capture because of potential infrastructure synergy. But overall, heavy emitters like oil and gas, cement, steel, chemicals are all notably missing. The only way to get these industries to engage is to reduce the cost of the CDR credits. And one way to potentially do that is to sign long-term purchase agreements that span anywhere from 5 years to over 10 years. This will probably require fronting a lot of capital because you're essentially betting on a strong technology that you expect will go down the right? So, and this made news because it was the first ever purchase agreement to value a tax credit at $100 per ton. But of course, Holocene is not actually operating at $100 per ton. It's now been acquired by Occidental, which will work to get the cost curve down, but it's essentially betting on a high impact technology. Similarly, JP Morgan and Chase also bought a 450 kiloton per year package of biogenic CO2 storage valued at about $200 per ton, which implies that they're going to try to figure out the CO2 transportation and storage costs. But this is what companies are actually buying today. But it's also worth noting that they're buying out capacity that doesn't exist yet, right? So it also shows why companies need to engage early. The figure here shows you what credits were actually delivered in the same time frame that they were bought in the last 2 years. So overall, it's only about 3% of purchase credits that were actually delivered, and that's mostly coming from biochar and pseudomineralization. DAC and BECCS, which had the highest purchase agreements, were actually the least to deliver, right? And that's expected because the commercialization timeline is just a bit longer and it's a lot more capex intensive. But to really assess which CDR technologies will actually scale and meet their deliveries, we like to look at it in terms of risk, right? Because risks can really prevent a project from becoming operational. And in the context of CDR, there are four main risks to consider. The first is carbon re-release or permanence. Right? So this can be as obvious as detecting a forest fire, but also more complicated, like biomass decomposition or rotting. Right? The second is advancing regulations, or rather uncertainty in regulations. Right? So will regulations actually allow you to even undertake a CDR activity? An example here is if a country decides that ocean based CDR and ocean based projects are off limits for environmental concerns, this basically puts a stopper on any new project development. The third is imprecise quantification and really everything to do with monitoring, reporting, and verification or MRV on CDR. Right, so can you actually quantify your CO2 removal and generate a durable and high integrity certificate for it? And the last is societal backlash, right? So communities might be happy with companies planting trees in their backyard, but they're less happy about CO2 pipelines. And we've seen that with projects like the Summit CO2 pipeline project in the US, right? And essentially, if there's no CO2 pipeline, any of the CCUS solutions can't scale. So we evaluate all technologies that we discussed earlier on these four risks and see how they fare. And that's what you see here in the Lux carbon negative framework. This figure has the average price of the carbon credit on the x-axis, which is what you would pay as an organization to offset with this technology. And on the y-axis, you see the composite risk. What you see here is that the land-based solutions, which are quite affordable, actually have some of the higher risk profiles, whereas mineralization or direct air capture carry the lowest risk profile, but then they do carry the cost premium. But as you can see in this graph, and we'll come back to it later as well, the most important aspect to really look at is that these bubbles are not static and they shift every couple of years, right? And there's three key factors that cause the position of these bubbles to really change. New pilots and demonstrations, right? So this can actually put new bubbles on the map as well, but it can also shift positions. So new projects are typically a sign of technology validation, and they're key for cost reduction as they scale, right? And deployment also helps with de-risking. So new projects can actually move one of these bubbles to the left or right, but also up or down. Second is changes in MRV and regulations, right? So the role of standard bodies here are really important, and reputed registries listing a credit is an important sign of de-risking. And lastly, technology innovation, right? So we've seen this specifically with the engineered solutions compared to nature-based solutions, where technology innovation is really key to bringing costs down, and technology innovation is the only reason you saw credits selling at $100 per ton. So the influence of these factors can essentially shift these bubbles, and we conducted this analysis in 2022, and today we'll see how CDR technologies have fared in 2025. Right, so 2 to 3 years later. Starting with higher price and higher risk, right? So we see that the price of nature-based solutions are actually increasing. So forestry or even ocean-based biomass sinking have a higher weighted average credit price today compared to what they did in 2022. This is probably a result of incorporating more digital tools for monitoring, right? And this investment has just not paid off in terms of risk because projects continue to be excluded in regulation and have faced failures. For something like biomass sinking, we increasingly see companies exiting the market, and offshore deployment has caused a lot of major spikes in the cost and the price of the credit. In the next decade, the trajectory of these technologies will not change too significantly, right? So forestry will continue to be an affordable credit, but increasing investments in MRV will not necessarily solve its digital challenges, right? So it's fine for corporate social responsibility and CSR activity, but not for sourcing high quality credits to offset industrial emissions. Insurance schemes will become more popular here. So, for example, buffer pools of carbon credits that can be cashed in when forest fires cause re release, for example. Right? So, buffer pools can reduce liability, but they don't avoid it entirely. And essentially, since risk mitigation costs for nature based solutions don't pay off, diversifying to engineered solutions are really a non negotiable. And that's what this trajectory shows. The next is when you have a higher price, but the risk profile more or less stays the same. That's what we see with a technology like enhanced weathering, right? So the current risk for enhanced weathering is not detrimental, but it's also not negligible, right? The price increase, while significant, actually makes sense in 2025 because deployment has significantly increased, and that has resulted in a lot of soil sampling. And for enhanced weathering today, 50 to 60% of project costs are essentially tied to measurement and data collection. And operational projects need to be monitored for several years to maintain the current risk profile, right? And not risk an increase. So in this case, continued deployment can actually lead to optimization over time, specifically for sampling density. But in 2 to 3 years, if the costs stay well over $300, $400 per ton, you will probably have better offset options at this price range. That's a lower risk. The big questions around technologies like this is whether the added and routine cost of MRV is actually worthwhile in the context of CO2 removal over time. Right? So, for example, Isometric, which is a standards organization, released a protocol for enhanced weathering in 2024. And since then, project developers like Eon and InPlanet have signed up to use it. So, what should you be monitoring for? Eon operates in the US, InPlanet operates in Brazil. If two projects in two different countries can run on the same protocol and show similar quantification, that can help reduce the risk of enhanced weathering and justify some of the cost. The third is when prices increase, again, probably because of MRV and digital tools, but the risk is actually reducing, which is good, right? So direct ocean capture and CO2 mineralization follow this trajectory. While the price increase does not necessarily attract customers, given the current stage of the technology, this is not necessarily a bad thing just yet, right? So actual deployments are providing learnings that have translated into showcasing permanence or better MRV and scale, right? So direct ocean capture, the price that you see on the screen here, it's actually one of the most expensive credits to buy in 2025 or 2026, right? So that's part novelty, but also part premium. So these are technologies that you do want to consider to be a part of your portfolio now that the risk is reducing. And now that the risk is reducing, you'll see a stronger focus on cost reduction, unless, of course, the market is willing to pay the premium. So, for example, for a leading company like Captura within ocean capture, Captura has begun operations of 1,000-ton per year pilot, which is a commendable feat for a technology which was basically lab scale 2 to 3 years ago. Right? So they've done this because of two reasons. One is their proprietary electrodialysis, which is tuned to step up production at off peak hours and produce a lot of surplus acid and base that the system requires. And the system can essentially use the stockpile as a reserve during peak energy prices, right? So the most expensive operating component of the system is actually only operating when energy prices are the lowest. And that's how they've been able to optimize. And second is with their partnerships. Right? So they started with Caltech, the university, then they trialed with the Port of Los Angeles, and now they've partnered with Equinor. And this largest pilot actually marks the first oil and gas collaboration with a direct ocean capture startup. And all of this is helping with de risking. But the last trajectory and the most favorable is lower cost and lower risk. And essentially, this graph tells you why interest and the need for CCS solutions still remains despite the higher price tag. Right? So, direct air capture, BECS, as well as biogenic CO2 or bio oil storage fall within this trajectory. And all of these technologies yield high quality offsets. Right? So, DAC specifically has shown a significant cost reduction, while $700 per ton still makes it very expensive to purchase at scale. It's a significant step down to where the transactions were in 2022, right? And that's the main thing to come back to. It's that companies are betting on future technology innovation and technology is actually getting the prices down. So we expect to see a lot more activity around biogenic CO2 storage, right? So this can come from the biomethane value chain, where or aging biomass cultivations that can be sequestered to reduce CO2 uptake. And a recent example is a company like Gevo that is entering the CDR market. So Gevo sold carbon credits from sequestering CO2 from ethanol production, and these credits were verified by Puro Earth. And after this happened, Frontier announced the launch of the first large scale rail based carbon management platform. And that's basically catering to how the US manages ethanol logistics today. But for these solutions, biomass sourcing is going to become a lot more scrutinized. So, for any developers active here, it's important to work in a contingency on potential penalties for inconsistent sourcing. So, to wrap up with the outlook and some key takeaways, if we come back to the figure of the carbon negative framework, right? So, direct ocean capture today is exactly where direct air capture was in 2021 or 2022 in terms of pricing, right? So, it remains to be seen if regulations and corporate stakeholders will let it go down the same cost and risk reduction curve as direct air capture, but for now, it is still worth monitoring. And as we move into 2030, biogenic CO2, BECS, and mineralization will increase quantity quite substantially. And we'll continue seeing a lot of near term supply from biochar, enhanced weathering, and similar solutions, which are much lower capex and can be integrated with, let's say, the agricultural value chain. But we do recommend exercising caution until the MRV is in place. And it's important not to only look at the attractive price tag in decision making. It's also important to consider the resource intensity of CDR, right? So energy consumption and capex, of course, dictates the cost, but resource intensity also includes land and water use, which can really increase the complexity in adoption, right? So today, engineered solutions have quite a broad range of energy use. So you have to evaluate companies based on their specific technology, right? So for example, for data capture, depending on whether it's electrochemical or thermochemical, the energy use can range from 3 to 9 gigajoules, which is quite a big spread. For biogenic CO2, if you produce bio oils, the energy use is 40% higher than if you just do a simple torrefaction, right? So in most cases, the credit quality is not compromised by the process itself, but the spread indicates that you can't generalize engineered solutions. Second, need for far field measurements increases land use, right? So land requirement for CDR extends beyond just the site of deployment. So if you think about enhanced weathering, ocean alkalinity enhancement, biochar, you have to collect data and do site analysis for far beyond the site of deployment to ensure that there are no broader ecological effects, right? So today, these far field measurements are not standardized and regulated. And we've seen projects where, for something like ocean alkalinity enhancement, the measurement needs to be taken as far as hundreds of kilometers for several years. Right? So this poses a big risk in scalability because it's just not feasible to do that. So overall, mineralization today is showing a good balance in resource intensity. So whether that's in situ or ex situ, it has the right maturity, but also quite manageable in terms of energy, land, and water use. And to end with some key takeaways, the conversation around CDR in industrial companies needs to move beyond just scope 3, right? So it needs to be aligned with existing decarbonization strategies. CDR is a pretty tactful tool to also just hibernate on any capex heavy decarbonization against current shareholder pressure while still working towards the same goal. And an example of that is biomass, right? So CDR can bring in a lot of private capital in the form of offtake agreements as opposed to building capex heavy projects, which helps you get a footprint in the biomass value chain. And this is useful as key players in biofuels and biochemicals are currently exercising restraint over high costs. So the ethanol industry or the biogas industry will become a lot more active in carbon markets over the next 5 years. This consideration, of course, does imply that you create risks for supply bottlenecks for long term biofuels and biochemicals, but in the near term, it does give you strong supply chain footing. The last is that MRV is good and important, but perhaps not indefinitely, right? It does help de-risk in the near term, but if in the next 2 to 3 years MRV does not show significant risk reduction, it essentially becomes a cost sink, right? And that's typically just a result of increased data sampling and analysis for new deployment. And of course, offsets don't replace abatement, and the Lux Carbon Negative framework is at your disposal to help you find the right options without the risk of greenwashing with carbon credits. So with that, thank you so much for your time and happy to answer questions.
Great, thank you very much, Mukunda. And as Mukunda mentioned, we are very happy to answer any questions you have, which you can type in the question box on your screen. And actually, there's a couple of questions that came in already, Mukunda. So I will ask you these questions. And the first one is around DUC and OAE. And the question is really, what's the difference between the two, and why were they positioned, differently on your chart?
Yeah, that's a good question because both technologies can use electrochemistry, right? So they can be quite similar on paper. The fundamental difference between the two is that OAE changes the pH of the ocean, direct ocean capture does not. So from an ecological perspective, direct ocean capture has a lower risk because you're not impacting marine ecosystems. The issue with something like OAE is because just because a technology or a project works in the North Sea doesn't mean you can deploy it in Southeast Asia or in the United States because the local marine ecosystems are just different. That's why the risk is much higher.
All right. And another question, and this time it's about biomass. The question is really around the competition between sectors. So do you think that when it comes to biomass relying credit, is the growth in those credit, do you think that it will impact the availability of the biomass itself or the biogenic CO2 for other applications like chemicals or fuels and so on?
Yeah, that's also a very good question, right? Because what you don't want to do is make a renewable source of carbon not accessible for applications that really need it in defossilization. At the moment, the CDR business around biogenic CO2 has just started out, but if it grows, it will compete. Right? So today there are three main ways in which biomass can be used to generate carbon credits. The first is solid biomass is converted into a slurry, typically with very fast thermal treatment, and that slurry is sequestered in wells, right? So in this case, it takes away from potential bionaphtha, for example. The second, biogenic CO2 from ethanol or biogas is captured and stored. This is less detrimental to supply chains because the CO2 from these applications is typically vented anyways, and typically e-fuels is much longer term. But biogenic CO2 may be less available for e-fuels if that does pick up, right? So then it would basically force the aviation sector to resort to data capture as an offset tool because it's going to be more expensive and that's your only other option. And the third is essentially just terrestrial biomass sinking. So this is actually just directly storing biomass and stopping it from decomposing. So there's very limited thermal treatment or anything of the sort. But in this case, you're entirely taking solid biomass away from the supply chain. And typically it's agricultural waste or secondary biomass, right? Not necessarily food crops. So whether you want to use that biomass for combustion or gasification, it won't be available. But with direct biomass storage, we don't expect that to scale as much because the risk of permanence is a little more pronounced and the biomass can just decompose underground. But essentially, if companies like Microsoft and other customers show willingness to pay for biogenic CO2 credits or biomass credits, it'll come down to regulations really prioritizing industry as the end consumers for that biomass.
All right. So there's a few more questions that also came in, but unfortunately we don't have the time. So as promised earlier, we will reach out to you with answers to your question. But for now, that concludes the webinar for today, and the slides and the recording will be sent to everyone who attended the webinar today. It will be sent by email. And after leaving the webinar, you will be prompted to complete a survey on today's presentation, and we would really appreciate any feedback you have, as this will help us improve future webinars. But for now, take a moment and check out our upcoming webinars on our website, and thank you very much for joining us, and have a great day. Thank you.